running a router, looking to use vacuum to hold your part, the vacuum is the only thing that you have. And that is what ties everybody together, regardless of what you're cutting, regardless of what kind of machine you have. If you have vacuum to hold your part, you're dealing with the same challenges that every other shop has. It's the vacuum that we need to use. A little about myself, married. Thank you for my wife, Margot, for joining us here today. 2 kids, 24 handicap. I wish that could be lower, but I keep getting phone calls from you guys that don't allow me to leave the office. So if I can get some more ideas across, get you guys running your parts, running them quick, running them fast, that's what we're trying to do. Maybe I can spend a little bit more time out of the office. And the biggest thing, I'm a believer in American manufacturing. I love my customers. I love their ingenuity. I love their passion for making parts. I love their ability to change on the fly. I also love the fact that we can do it here now in America with automation technology. We don't have to send these jobs to China. We can do it here. And I think if we do it here and we try to compete against China, trying to make widgets, we need to do it faster here. We need to do it quicker. We need to do it more efficient. And in order to do that, we need to run our parts as quick as we can. And if vacuum is the only thing that's holding on to our parts, why do we not hold on to them better? Just to think that, man, this isn't working, I'm going to cross my fingers harder next time to see if it works, that's not going to work. We need to adjust the ability to use our vacuum properly. So, before I get into a whole bunch of gasketing concepts and techniques, let's waste a little bit of time. Classic cartoon here that always reminds me of the people that I get to on the phone trying to get this idea across. So many people tell me, my vacuum does the trick. My vacuum does the trick. I know for a fact a proper gasketed solution can do much cooler tricks. We need to be able to figure out what is the right solution for each shop, and if we can do that, we can stop spinning our square wheels, spend a little bit of time, think about it, readjust how we can do this, not just do it the way we've been taught, but let's think about it and figure out if there's a better way to do things. For instance, the classic banana. Everybody knows a banana. Everybody's opened a banana. Everyone has eaten a banana. The very common way people eat a banana, peel off the tip. Man, now the top came off. Not a very efficient way of opening a banana. Very easy differential is the way monkeys eat bananas. Monkeys don't trouble themselves with the broken tip of a banana. Monkey just squeezes the bottom, uses the tip as a handle. I have never opened a banana from the top since the day I was taught that lesson. And I think gasketing solutions can do the same thing. You realize for so many years you've been opening the banana from the wrong way. If we can just change it up a little bit and say, man, that makes a whole lot of sense. If we can just rethink about how we do things, there may be a better way to do it. And I think that is the most important thing that we're trying to get here today is yeah, the system may do the trick, but let's do it better. Let's do it better. So here we are. There's my PowerPoint presentation trick. And here we are, improving vacuum performance of CNC routers with Gasketing Products and Techniques. Like I said, been coming here for 20 plus years. More and more companies are using CNC router technology to make their parts. More automation, more robots making stuff the way the industry is trending. Not only are there more companies using routers, the number of companies providing routers is also growing over the years. Como router, like I say, they were the ones that got us started in the industry. I'll be forever grateful for that phone call that my father received in 1996 to get us in here. Been around for a long time. If I was to use this list alphabetically, AccuRouter may be the first name on the list. Another provider of routers to the industry. Multicam in Texas. Not here this week, but also a provider of routers. Legacy in Utah. These guys are here this week, just added vacuum to their table. They used to use just a gantry system. Now they've started to use vacuum to help hold parts. DMS, they're here this week. CNC Factory, Chris and his team have their big new booth this year. Styles and Wiki, always a presence. Axes, our friends in Canada. Laguna's here. Anderson, CMS, Bucelato, Biasi, Industrial. We get the idea. There are a lot of different companies providing routers to American manufacturing. The thing that ties all of these guys together is the fact that they're trying to get their customers to hold parts with vacuum. A lot of differences here between these machines. A lot of differences in their style, whether they're a flat table, whether they're a pod, whether they have 40 horsepower pumps or they have a 5 horsepower pump. Regardless of what machine you have on this list, you're dealing with vacuum, and you're trying to get maximum performance of your vacuum. That's what we're trying to do here today. So every shop we talk to has their own unique set of variables. Obviously, the type of router that they have at the very top of the list. First question I have for somebody when they call us to help with their vacuum performance, what kind of router do you have? Just gives me a quick idea of what kind of shop we have. Gives me an idea of the vacuum strength that they have on their machine. Everybody has a different vacuum power, a 40 horsepower pump versus a 5 horsepower. The size of their parts, obviously a big deal in terms of their ability to hold that part successfully is the size of the part. Maybe they have a few different routers. Maybe their Como runs differently than their Anderson, so they're going to have some challenges in that regard. Everybody comes with a different background, different history of ability to run CAD, CNC work. Maybe somebody's done CAD work, but only on the mill and not familiar with vacuuming. They're always clamping, and the vacuum hold, completely new world to them, and sometimes there's a learning curve. So number of employees, number of jobs. Maybe there's 3 shifts, and Dave runs it in the morning, Steve runs it in the afternoon. Do they do things differently on that part? Up spiral, down spiral cutting, that's going to have an effect on the ability to hold a part. Your feed rates. A guy in Denver is going to have more trouble holding a part than the guy in Miami, just because of elevation challenges. The materials being cut. A thin plastic acrylic sheet, going to be a little tougher to hold on to perhaps, or a little easier maybe than a warped plywood. I mean, all the different materials have different characteristics to it. The tooling quality, dust collector strength. Sometimes your dust collector is going to pull up a part. So all these different things, spoil board versus dedicated fixture material, we'll get into that here in a little bit. If your hoses, sometimes people just concentrate so much on the top of the table, you realize you got some leak, some vacuum leak under the table, your hoses and your pipe fittings, all these different spots where the vacuum is being lost. And of course, gasketing performance. If you got gasketing in your table, the machine probably came with gasket in the edge perimeter. If you haven't replaced that in 6 years, there's probably some performance differential that's happening there because you don't have that fresh, clean seal in there. And more. There's the amount of variables that each shop has is almost limitless in terms of how they're attempting to hold these parts. And every shop, with all of those variables, all those different kinds of machines, ultimately is playing one game, the pass-fail test. Were we able to hold our part successfully? Yes or no? That's what it comes down to. Part size goes down. Vacuum loss in the system goes up. And at that point, that customer can't hold that part, whatever it is. His part is too small, his vacuum loss is too large, and at that point, we can't hold that part. So there's 2 things we can do. We can either grow the size of the part, which isn't really practical because that's your part. You got to cut your part. So the only other thing we can do is increase the vacuum, decrease the loss of the vacuum. The vacuum pump that they have most likely is strong enough to hold the part, but it's the amount of vacuum loss that's occurring that is having a negative effect on the ability to hold that part. So for a second, let's talk about vacuum. Everyone's using it. Vacuum. Anyone who's ever been taught by a nun in school may have used Latin terms. Vacus is the Latin term for vacuum. Vacus means void of matter, void of air. It does not mean vacuum cleaner. Too many people think of a vacuum cleaner as how they're going to hold their parts on their CNC router. Just suck a vacuum cleaner right through an MDF board, and hopefully that's strong enough to hold my part. But vacuum the void of air under the part is what needs to be this aha moment for everybody in terms of what we're trying to accomplish in successfully holding a part. And we need vacuum under the part. 30 inches of mercury is perfect vacuum. That is completely void of air. 30 inches of mercury is not achievable on this planet. We don't have the ability to remove all of the air from a void of matter, of a pocket. But the closer we can come to that, the closer we get to true vacuum under a part, allows for the atmosphere that's above to sit on that part and use science to clamp it down. And that sealed edge of gasket material is the tool that allows for a sealed edge. If we don't have a sealed edge, we cannot create vacuum. We can use airflow, and that's what the majority of shops are doing, is airflow. And if that's sufficient for you, great. I'm not here to slow any train down. If everyone's cutting parts and they're doing it successfully, I'm rooting for you. It's the calls that come in is because they can't hold the part. And we need to use that gasket to get a seal to hold parts better. So, getting into the different types of gasket solutions that customers use. The first one that we came up with at All-Star in an attempt to get better weather stripping was the grid gasket. Grid gasket is material intended for any CNC router that uses vacuum to hold parts. That list that I showed there earlier, 35 names or so, I've got a binder at my desk for each one of them, how they run their machine, what their tables look like. Every one of them was a little bit different, but they all need a gasketed perimeter on the base of the table in order to prevent the vacuum loss from occurring from the system. That includes pods. Some machines that use pods versus a flat table, same systems apply. We need a gasket seal in order to prevent that loss. And very often, whether you're buying a machine in the future or just bought when you're at training, that line that you're told, make sure you get some gasket to seal under the spoil board. Make sure we get a good seal under the spoil board is something that most everyone who's purchased a router has been told at some point. Acts as the lip of the freezer door, right? Your freezer at home has a lip on the door. If you didn't have that lip on there, you'd be leaking a lot of cold air out of your freezer. Gasket material does that same thing. Just creates a lip to keep that pressure, that vacuum pressure, that cold air in the system. If we didn't have a seal, we'd be leaking. Now at home, you can get a stronger motor and make colder air in your freezer. But if you don't have that seal on there, it's not very efficient, not very effective. So we need to capture the vacuum pressure, we need to capture the cold air of the router, and we do that to start with grid gasket. One thing to keep in mind, picture like this here, this is an industrial CNC machine. They build their machines with zones. So when you do have the option of turning off a zone, turning on a zone, they all have to be individually gasketed for. I've been to some shops where they say, I've got zone A, we take off the spoil board, and there's no gasket separating zone A, zone B. We can't turn off a zone if there's not gasketed sealed. So we need that freezer lip door around each one of those zones. And probably the most important thing, one size does not fit all. Every machine manufacturer mills their channels at different sizes, different lengths, different table layouts. So there is no one grid gasket material for everybody. When we are looking at grid gasket material, we talk to our customers. We've got a couple of rules of thumb that we like to give to them. One is it's a non-adhesive material. Some machines come with an adhesive product for those channels. We prefer to supply to the customers a non-adhesive material. This gasket does need to be replaced from time to time. The fact that it does need to be replaced, kind of like the oil in your car, you want to have a clean peel. Don't want to leave any adhesive residue in there. So a non-adhesive material is the best bet. Like I say, change it like the oil in your car. Everybody drives their cars a little bit different, so how often is up to you. But as you can see here, we have this gasket lip proud above. That's what's going to create our seal. Down here, what's under the surface, 80% of that gasket doesn't even get used. But it's this 20% lip up here that's creating the seal. But if you get to a shop and it's now flush with the table out here, there's going to be a lot of vacuum loss occurring right across that table. So that is that lip, that 20% lip proud above the table. That's what's going to create your seal. You need that lip above there. Once you run your finger along there and there's no gasket, it's not doing much, and that's where you get some of those percentage points of loss. A little vacuum loss here, a little vacuum loss there, all starts to add up. Round pegs don't fit in square channels. Another big thing to keep in mind. A lot of the router manufacturers out there will supply a round gasket with their machines. The most common channel size these days, 1/4 of an inch wide by 1/4 of an inch deep. When we have a 1/4 by 1/4 channel, most gasket provided by the CNC router manufacturers is going to be a 5/16 round cord, 8 millimeters. It's probably what most of you, I'd say about half the machines right now are built with this 1/4 by 1/4 dimension off the NEMI grid layout. They'll supply a 5/16 cord for that 1/4 deep channel. So it's larger than the channel. And we need that larger because you need that lip proud above, right? Like I said, you need that lip to keep that vacuum pressure in. But when we supply a 5/16 cord in a 1/4 inch wide channel, it's also wider than the channel. It's taller, which we want, but it's also wider than the channel. And when you ask your human operator to get that gasket into that channel, you got a little wave there, right? Why is there a pinch here? What's going on? And if the lip on your freezer door at home has a bunch of wave to it, I know for a fact you're leaking cold air. So what we do is cut square gasket for square channels. 1/4 by 1/4 channel should be a 1/4 wide gasket, so there's no stretching needed. Sticks above by a 1/16 of an inch to create the seal, compresses down into the channel, and get a flush, consistent, tight seal all the way around the table. That gets the system started. We need a tight seal, an airtight system under the spoil board, and wavy gasket doesn't help that situation. Again, my current setup does the trick. I get it. This may work. It may work. This works better. We're trying to create seal. We're trying to create as efficient of a seal as we can. Every system does the trick. And we're trying to get to 30 inches of mercury, which is impossible. We can't do it. But the closer we get, the better off we're going to be in the ultimate test. Can we hold our part? That's why we're in business. Let's hold the part. We need to get that vacuum pressure to the part. This is going to get a couple points of loss. This is going to be an improvement. So a couple of grid gasket examples. I've got a couple other photos up here. Pod, again. Some machines have pod and rail systems. You can see the gasket material in there. Same kind of rules apply. We want the same width as the channel, sticking above by a 1/16 of an inch. Another table here. This is a Techno Isol machine. Show this as an example, last slide for grid gasket, just to see that hopefully you can kind of envision if we don't have a seal in here, how much vacuum loss we're getting, right? That's why the gasket material is in these perimeter channels, is to prevent that loss, to prevent that leak. And that's why that gasket in there is so crucial, why every machine provided has that material in there. Yes?
Good question. All the CNCs that are running out in the shop, do you know if any of them are running your gaskets on there?
Most are.
Or are they all just siliconing down a piece of MDF?
Well, most should have the gasket material in the perimeter of the table. You could silicone down. If you're going to silicone down, the reason you do it is to prevent the air loss. That's why you're siliconing that down. Now, my different ways of doing it, most customers are going to change out those spoil boards. They're going to fly cut it, or the folks that make dedicated fixtures, they're going to want to change those on and off. A lot of times when customers are talking about taping the edge or siliconing the edge, a lot of those steps do the trick. We're all trying to do the same thing, prevent vacuum loss. Silicone can do that trick, but from a production point of view, in my opinion, let's use the gasket or the vacuum as much as we can. The vacuum pump is there. It's a strong, powerful pump. You've paid for it. We just need to make it as efficient as possible. A gasket material out in the perimeter, certainly the strongest way to do it. The silicone method will do that trick, but then from a production point of view, is that peeling off? Do you have to put it back on? Do you have to scrape it off when you rechange your spoil board, change it over to a dedicated fixture? Siliconing, you may miss a few spots. So yes, you can do it, all trying to attack the same issue of vacuum loss prevention.
Let me reword my question because I think I sent you the wrong direction. All these CNC manufacturers out on the floor, are they including gaskets with their CNC machines?
Yes, yeah, yep. Some of it is our material. Some of it comes from overseas when the machines ship here from Italy, from China, from Germany. The machines will come often with the round cord. That's why so many shops will tell me, will get the call and say, I've got a 5/16 round cord that came with my machine that I need to replace. And I'll often say, we have the 5/16, but talking to them, we get back to the square idea, and maybe that's not the best option for that particular machine. So yes, every machine will in there, you can pull up all the spoil boards down there on the show floor, and if they're not running gasket in that material, or in that table, well, we're also at a show. So remember the magic of Hollywood. A lot of these guys cutting parts out there aren't really cutting parts. They're making it look like it because there are challenges in holding parts. And when you're trying to show the capability of a router at a show, you don't want to present the problems, the challenges that the machine's going to come up against. You want to show its capabilities. And that's why the guys down there will often say, our machines don't need gasket, which to me is just throwing science out the window. Like, you can say we don't need gasket. I understand. They're all going to compete against each other. They're all going to say, my machine doesn't need gasket. Those are the guys that have the slower machines, the weaker machines that need the gasket. Our machine, we don't need it. But hopefully by the end of this presentation, seeing what gasket does, what it's capable of doing, it is so important. It's not critical. It's not you can still hold parts without this. I go back to my original line. The system works. My system does the trick. I get it. You can run it real slow. You can do 17 passes on a part and finally get it done, and you did the trick. But we got to get the right seal in there. We got to get an airtight system. Before I move on to the next slide, any other kind of questions on the grid gasket concept in tables, in the router itself before I start getting into, yeah?
Under ideal situations, I think I'm taking this as a mercury when I have a rover beam. What should we be shooting for? And I have a round gasket, that's what comes with the machine. If I change over to the square, will I be able to increase that into mercury?
I would guess, without knowing all the variables, I would bet $1 that if we went to your shop tomorrow and changed that round cord out with a new square, fresh bag of gasket, you're going to get performance improvement right away. It's noticeable quickly.
Do you know what most machines are pulling in ideal situations?
And that gets back to all the variables that occur. Somebody that's running an MDF spoil board versus an LDF spoil board. Somebody that's in high elevation, lower elevation, all those things kind of to change in. And I have a limited skill set. I am a gasket guy. I have never run a router in my life. Those routers scare me. I don't know how to turn them on. I've never cut a part. So I have a lack of knowledge on the day-to-day operation of a machine, but talking to these guys for 25 years, I know the challenges they're up against when they're trying to use their vacuum to hold their part. So I'm always interested in improvement. I'm trying to get from A to B, and why someone's at A, I'm not always sure about, but I'm trying to get them to improve. And if we can get that number from 8 to 18, and you can tell me we're making progress, that's what I'm trying to do, is make progress. Because I don't know why it's only 8. And there's a lot of things that I don't know. Ask my wife. There's a lot of things I don't know. But if we can seal better, if we can continue to clamp better and prevent loss, that number is going to go up. Oh, for sure, for sure. I can go into any shop in this country tomorrow and improve their vacuum performance. Now, do they need improvement? Maybe not. Right? If they're cutting large parts, they can do it all day long without vacuum improvement. But it's when you get into that trouble, that point where you can't hold that part because the part size is smaller and vacuum loss is increasing, That's the guy that needs to say, hey, I've got a really leaky system. The guy with the big part, he's got a leaky system too, but he doesn't maybe notice or it doesn't affect his ability to hold those parts. Yeah. Yes, sir.
In the school situation, we use gasketed pods and a venturi system, and we use 25 all the time. So there's
Get one more technology.
At 19 to 25, we were doing with the venturi and holding parts, but gasketed and pods.
Yeah, you need that.
Less than that, we wouldn't have been able to do anything.
Yep.
So we took advantage of great sealing, weak power.
And if you have the great sealing, you can make up for the lack of power. Because the lack of power isn't, yes, it's a challenge, but it's something that can be overcome by continuing to seal. It's the loss, the vacuum loss, that's the issue. When vacuum pressure loss leaves the system, little here, little there, that pressure never comes back into the system. And when we're trying to hold a part, this is why we're in business, right? To hold parts, not spoil boards. We want to hold the part. We need as strong of a clamp on the part as we can get, and all that's occurring is having a negative effect on the ability to hold this part. But the grid gasket is the base. That's what's crucial about getting your setup started, the foundation of the house, so to speak. Then, once you get that foundation of the house set, now we're moving on to spoil boards or a dedicated fixture. Those are the two directions I'm going to send a customer into. I ask them, one, what kind of router do you have? So I get an idea of what kind of shop I'm dealing with, what kind of machine they've got. Two, are you doing repetitive parts or are you doing custom parts? No wrong answer. Just I'm curious. Are you going to do repetitive things? Are we in a production environment? Or are we doing short runs, constant changeover? Two different ways of doing it. The spoil board, to me, spoil board is a board that we spoil. That's why it has the term spoil board. We're going to spoil it. We're going to chew into it. We're going to sacrifice it. We're going to eat into it. Because we have all of these random parts, all of these constantly changing parts. You need that sacrificial piece. Typically MDF, LDF, straight downdrafting through the part or through the board, allow that vacuum to come through that board. Good for the parts, like I say, always changing. You need that sacrificial piece in order to do that. Certainly, without question, the most common method used across the industry. Ideal for many shops out there. However, not ideal for everybody. I think for the folks that are doing the production runs, we prefer dedicated fixtures. When somebody says to me, hey Mike, I built myself a dedicated spoil board, I get really confused. I don't know what a dedicated spoil board is. Are we dedicating it or are we spoiling it? Those are the two different methods, right? We're going to spoil it because we're chewing into it, we're sacrificing it, or are we dedicating it for repetitive use, repetitive work? Dedicated fixture for repetitive use, repetitive work, best for those production run environments. What I like to teach my customers, instead of an MDF board, let's use a non-porous material, Baltic birch, HDPE, something that doesn't allow vacuum to pass through there. The reason we don't want vacuum to pass through there is to become more airtight. We want an airtight system. If our board is airtight, we're not leaking vacuum through the board itself, through the fixture board. Now, of course, it takes a little time to build one of these. Right? You got to do the CAD work. You got to create this board. You got to invest in it. You got to buy it. You got to make the time to create this. But if we can make a proper dedicated fixture, we can hold parts better. We can eliminate onion skins. We can eliminate tab cuts. We can increase feed rates. We can get cleaner edges. We can improve tooling life because we're not getting bits snapped. All of the benefits that you get from a properly held part solidly comes from the time invested in making a dedicated fixture. Like I say, we're working towards creating that airtight concept. The more airtight we are, the less pss, 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 pss that's happening, the better we're going to be when it comes time to get that vacuum pressure to the part. So, yes, sir. It can be. Yep, it can be sealed. You could also, one of the jokes I give to customers is, if you want a convertible, go buy a convertible. Don't get a sedan and cut the roof off. Like, you're spending a lot of time painting, sealing, hoping that you get 100% coverage on an MDF board, where chances are you didn't get 100%. You missed a spot here or there. It's tough to see. And the other thing about MDF is alive. I mean, it's breathing. It's expanding throughout the day, depending on how much moisture is in the room, the heat. That's why you get a little warp and swell in a board. And if you make a dedicated fixture out of MDF, if you make a board like this, spend all day making a museum quality fixture, you're going to lose some of those numbers that you dialed in, spent all that time creating, because that MDF is changing. It's warping, it's swelling over time, twisting. So you go back to use that dedicated fixture in a month, and your numbers are off, and you're getting some miscuts. It's because the board actually underneath is starting to change. Yeah. That's another option. Yeah, and like I say, go back to one of the first bullets. American manufacturing, man, I've got customers using everything. I mean, a lot of shops have so much waste at their disposal that they'll make fixtures out of some of the stuff that they already have in their shop. So it's the concept that's probably most important is, what do we need for an airtight system? That for a dedicated fixture anyway. And yes, that kind of material, melamine, HDPE, Baltic birch. Someone can seal an MDF board. You don't have to use, I've seen plenty of customers who will make a dedicated fixture out of an MDF board. Again, it does the trick. Is it the best trick? I don't think so, personally, but I'm not running the job. I don't know, MDF may make more sense than I even realized for that particular shop. But the concept of airtight is what we're trying to produce. Dedicated fixtures does a better job of allowing yourself to make that dedicated fixture, because you know that's the job, and let's just make a board that is airtight all the time, versus that spoil board where you don't have that ability. You want that adaptability to make any part through a universal downdraft board.
For your dedicated fixtures, are you still skidding that dedicated fixture?
You don't need to, because there's no vacuum draw coming through it. What you would need to do is put and some of these other pictures will show it. In fact, let me get into some, but here is the vacuum source hole. So you'll have your vacuum, because it's a non-porous board, you need to create your vacuum pocket hole. You need to create your vacuum source through your dedicated fixture board to pump that vacuum, port that vacuum from the table to the part. And we can get into, so inboard gasketing is the best solution, ideal for holding parts. To make a board with channels, let's see here, inboard gasketing intended for when we start to gasket for parts. Right, to this point, everything is at the table. We start talking about dedicated fixtures, spoil boards, whatever the case may be. Once you've decided, yes, I got a good seal under the spoil board. My rep told me get a good gasket under the spoil board. Let's not leak vacuum under the spoil board. But I know no one buys routers to make spoil boards. We're trying to hold parts. That's why we're in business, to hold the part. And now we've taken care of the first half. We've gasketed our table. We've done half the battle. Now the other half is sealing for the part. So once we start gasketing for parts, that's a little bit more of a challenge, especially for the guy that sells you the router. Right? We're in a capitalistic society. That guy's probably more interested in selling his next router than holding your hand to help you hold your parts. That's just the nature of where we're at. So because shops do so many different things, a lot of parts, small parts, big parts, small parts, plastic, wood, there's too many variables for the guy that sells you the machine to kind of get his head around. But this is where we can start to talk about what is best for your particular shop. So when we start doing inboard gasketing, dedicated fixture environment versus a spoil board, right? Inboard gasketing for dedicated fixtures, repetitive parts, the absolute best way to do that. Got an example of a board here with channels. The advantage of having gasket in a channel, recessed, that gasket never zeroes out, doesn't flatten out completely, never gets maxed out. It's only compressing, just like the gasket in your table, it's only going to compress to the height of the channel. Right? It's only going to compress that much. It never gets maxed out. So it has extended lifetime, extended recovery to that. Insert into a pre-routed channel for that gasket material to rest, so you know exactly where you're doing it. Your own CAD work with an offset can design, this is your part, and then you got your gasket channel in here to mirror the inside of your part. Best for those doing repetitive parts, looking for tight Z depths, all those different things that a inboard gasket brings the part flush up against the fixture, like say, ideal way to do it. Our rules of thumb when using this inboard gasket concept, we want a 3-to-1 ratio roughly. Same kind of number that we have in the table itself. 3 parts of the gasket under the board, 1 part above to create that seal all the way around the part. Other folks making dedicated fixtures, one thing you want to consider when using a non-porous board, because it's non-porous, we don't have universal downdraft. So we need to tell the vacuum where to go. Not only are we trying to hold our part, but we also need to hold our offcut, right? We have waste here. And without vacuum, universal downdraft through an MDF, you want to make sure your waste isn't flying across the room. So we gasket for the waste parts so those don't fly off. Good way to do it, I tell customers, is 3 parallel pads. You have your tool path here that we're going to use to cut the part. Just to the inside of that, we'll downsize the program, run our gasket channel, and then to the inside of that, the third path, I like to use as the vacuum path. There's your vacuum source hole right through there. Because right here is where the torque is occurring, right? That's where the tooling is ripping through the part. That's where the part wants to move, is that tooling pushes its way through the part. That's what's causing the movement. So the closer we can get the vacuum draw, the vacuum clamp to the tooling, the better off we're going to be. The torque isn't happening in the middle of the pizza, it's happening out the edge. You know, we want to get that edge accounted for. That's why I put that vacuum channel, connecting it to the vacuum source. Yes?
Back to that previous slide. So I'm curious, is it because it's so thin, so you don't need that's sufficient to hold it? But if it's, say, if it was a thicker part, or then do you want that vacuum chambered or void to be larger? In other words, utilize some of that real estate inside?
So you could, and a lot of this comes down to customer preference, how they do things. But conceptually, the way the science works is this channel here, is this what you're asking? Let me make sure I'm getting the question right. You're asking, should this be wider, this vacuum channel? Where as long as it is a channel, and we have the ability to pull the air, pull the vacuum, pull the molecules from here, we create vacuum. We create that vacuum clamp through that channel, regardless of its width or its depth. In fact, the deeper and wider this channel becomes, the more volume the vacuum has to remove from the system. So sometimes a shallow channel without much air volume is a little bit easier for the vacuum to handle. Just pull that out of there and we've created vacuum. Once the molecules are gone, doesn't matter how big it is, it's a void of molecule that we're trying to create. So you can change that. Other customers may grid it out, or they'll make, some have I think we got another photo here about a troughed area that I can show you. But yeah, as long as you have that vacuum clamp area, I think that the channel size, not that it's irrelevant, but the concept of making a channel that we can pull the air from, not bigger isn't always better. We're not trying to get more air out of there, it's just the air. Yep. Yes, yep, the waste, or not only the waste, but this part here, I think I may have missed it on my bullets here, but this particular customer, this particular job had a hole in his part. He had a center hole right there that he punched in. And when he punched that hole in there, if you don't account for it, your vacuum pocket area has become compromised, right? The gasket is the walls of the prison that we're going to use to keep that vacuum engaged, keep that vacuum pressure in the system. And if we punch a hole in the part there, our vacuum chamber area has been compromised. So we need to put a little gasket ring there so when you punch that hole in there, your overall pocket doesn't leak air. We have that same system.
What material is that
That, I believe, is a UHMW for a fixture. A common, another, or maybe an HDPE, something, a man-made, non-porous material. Yep, doesn't twist, doesn't warp over time. So he can store this fixture over on his fixture rack, put maybe he's got a code on here, UAO, I don't know if that's cool, but go to shop and they've got all their dedicated fixtures. Maybe they write it on the side, and this board theoretically shouldn't warp, shouldn't twist over time. It's a structurally sound board that they can use 6 years from now, and it's still the same board. For the spoil board? Yeah, if you're going to lean it up against it, you may get that twist. So we've seen shops will have their to flatten it back out. Yeah, the vacuum will also flatten it out, but the more flat, the more consistent we can be, the better. That way you're not asking that vacuum to flatten things out. Let's keep it flat, keep that vacuum working towards where it wants to work. Another thing that we can talk about, just a quick rule of thumb that we like to do, customer was doing some parts here, and their depth of cut was critical. They had a critical Z depth. So one thing, it's tough to see here, but one thing a lot of customers will do is they will chamfer the top of their channel here slightly. They roll out that 1/4 by 1/4 channel, or 1/4 by maybe 3/16 to leave that 1/16 of an inch sticking above there. And with a slight chamfer on there, like you may see in your tabletop, that allows that gasket a little extra wiggle room to zero out. And on a customer like this who had very critical Z depths, they were making this round over on all these small parts. It was tough to hold on to all this corian, slick material, hard material, making a dedicated fixture. They're trying to do it in one pass. They allowed these to make. So to make this dedicated fixture, rise it up, get that profile edge on there with a chamfered gasket seal, brought everything flush, had that Z depth, that Z tolerance tight because it's tight up against the fixture. The chamfer, like I say, it's tough to tell with the gasket in here, but it's right along there. Just like you would, if you take off your spoil board, a lot of the machines will have their 1/4 by 1/4 channel with just a slight 45 at the top, just to give that corner a little wiggle room to go into. If your table doesn't have it, that's fine, but you can take that same approach, give the top of the channel just a little extra. This is a 1/4 wide gasket. If you route the channel 1/4 wide and you have such a tight Z depth tolerance, you want that gasket to zero out completely. And if there's a little bit of wiggle and that corner pinches, you don't want that. You want that gasket to zero out, and if it needs a little help to give it a little extra room to go down, whether it's chamfer or maybe you come back with a 3/8 inch bit to give it a little step, just something, a little extra room on the top for that to go down. Now it may not be necessary. If you don't need to put that chamfer in, why do it? But if you find that, especially big customer group we have these days is the outdoor poly furniture. Very thick, dense material, a lot of grain made in there, man-made grain, so you can't, it's very rough. So what they do is they will take some of this gasket, but they need a lot more clearance because the variance in the material is more than a 1/16 of an inch of a lip of a freezer door is ready to counteract. So in order to counteract for the variance in the outdoor poly furniture, they need to have more clearance above there. But the taller that gasket becomes, the tougher it is to zero out into the channel because it gets a little top heavy. And if it pinches, you're going to have a tough time holding as tight of a tolerance there because your gasket is pinched between the two surfaces. So go a little taller, get the channel at the top a little wider to give that gasket a true chance to zero out.
Were the gaskets into the gaskets glued?
Yes, all our products, the grid gasket material for the table itself is a non-adhesive material because we don't want to gum up those channels. But when we start talking about everything else, all the part gasketing, all of these are adhesive back products to help anchor it into the system, anchor it into the spoil board, anchor it to the fixture. As you're taking parts on and off, blowing the table off, all of it is anchored in place with an adhesive, not a bonding adhesive. This isn't stuff that's sticky and you're gonna have a tough time, but it's enough tack to keep it in place, keep it from sliding, peel it off if you need to, but all tacky enough to keep it in place because we know we're cutting parts and we need to keep that gasket in place.
Talk about the ends of the gasket.
The ends of the gasket, do we have a spot here where we can see like right here you're talking?
Yes.
No, I recommend don't do anything. Even in the table, anywhere where you join a gasket together, best off just doing your best to push it up against each other because if you glue it, we don't know if that glue is going to harden differently than the foam. That foam compressible sealant will compress to each other too as well. Maybe if you really want to get crucial, maybe a scissor cut versus a tear. A scissor cut gets everything flush. Some folks will even 45 it. But really, the amount of vacuum leak that's going to occur right there is minimal in the overall scheme of things. But you're absolutely right. I mean, we're talking every little bit helps, and we want to make sure that that gap is as small as we can in order to create the best seal we can. As we go through some examples, if there's any questions on inboard gasketing, happy to do it. Here's a guy doing some knife handles. Obviously small, narrow parts, difficult to do. If he was trying to do this on an MDF spoil board downdraft, very difficult to cut something with such narrow parts. So we just put some gasket into some channels, put some holes in there. Here's an example, the poly furniture. One of our big customers up in Canada, where they route the channel. This is an interesting one. Routed the channel to bury their gasket, put their vacuum source hole into the fixture to get the vacuum to the part. We can't really tell here. He was having troubles. This guy was ordering so much gasket. He said, what are we doing wrong here? I mean, I love your calls, but why are you replacing this stuff so often? It doesn't make any sense. And we got to talking about it. He had troughed out this entire area, which is another way to do it. I talked about either running the vacuum channel or a grid system. What he did was he troughed out the entire area. So this is lower than the actual fixture material that's out here. But what he did is he troughed out the whole thing, and this gasket was higher, the channel was higher on this side, and he had a lot more gasket exposed because he troughed it down so low. So about half of this gasket was sticking up, and he kept pulling it. The vacuum kept pulling the gasket towards the source because he had so much of it sticking out of the channel. And all we did, we made the slight adjustment. The next fixture he made is he just left a slight wall there to keep that gasket in, troughed out the rest, but just left enough of a track for that gasket to rest in, and huge improvement. It was a small little thing we caught, but major difference because the gasket was leaving where it was supposed to be, and we're not getting that perimeter seal that we're trying to get. So, I get it. We're dealing with real world scenarios. Not everyone is going to make a dedicated fixture, right? No one wants to spend 95% of their time building a dedicated fixture for a part they're going to do one time. So how do we still get a vacuum clamp on there? How do we seal if we're only going to do this one time or 10 times, 50 times, not 1,000, 10,000? We use onboard gasket for that solution. Onboard gasket, real quick, real easy. What is the intended use for onboard gasket? Quicker fixturing. We don't want to spend all of our time making a dedicated fixture. We don't want to route channels. We don't want to do the CAD work to route. We don't want to put the vacuum source hole. Want to do something, but we still want that vacuum clamp seal. So we're going back to a spoil board environment, dedicated fixture versus spoil board. The spoil board, high flow through, constant downdraft, but without a seal, it's just a waste of downdraft, a waste of energy in a way. So the shorter runs, production type work, and you can use your existing CAD work. So what somebody will do is, you've already done the CAD work, right, to cut your part. You can't skip that step. If you want to try to cut a part, CAD work's already been done. So run that CAD work, scar your MDF spoil board, you see where that part is going to lay out, and then you just take a self-adhesive gasket material, stick right to the surface of a spoil board, no channels needed, just trace to the inside of your tool path, and when you throw your sheet material on there, turn on that vacuum, all of these cutting boards are clamped in place even before they are cutting boards. It's still a full sheet of material, but those, you turn on that vacuum, all those parts are clamped in place before the tooling even starts touching the material. And that clamp keeps that thing in place with a couple of minutes worth of time investment, which eliminates the need for the onion skin, eliminates the need for the tab cut, eliminates the need for somebody to go clean it up on the wide belt sander. If we can get the parts held properly with a quick setup of gasket material, that's what we're trying to produce, is that vacuous area that we can create vacuum under the part. So, quick few rules of thumb when we talk about the onboard gasket material. Thinner the better. We got a 1/32. A lot of our customers dealing with plastics, man-made material, no warp, no grain, dead flat. They can use a very thin gasket material, 1/32. Most of our customers with wood, with grain, with a little bit of warp, will use the 1/16. You just need a little bit more of that lip of the freezer door in order to seal that warped door that you have. 1/8" material for the folks doing really warped material, or maybe some of that outdoor poly furniture I was mentioning. Different products need more variance. But why do we want the thinner the better? The thinner the better, the less jello effect that gasket is going to produce. Not that we'd ever do something 1 inch thick, but if you had a 1 inch thick piece of foam on the surface, and you start to cut that apart, you can imagine how much shake that gasket would produce. You don't want that thing wiggling around as you cut it. So the thinner the better, the less variation, the tighter your Z depth tolerance is, the more you know where that part is. But at the same time, if you got too much warp, you're going to need a thicker gasket just because of the nature of your material. And the more varied the material is, the tougher it is to hold. That's why those poly furniture guys need so much gasket, is because it is so varied and it is so difficult to just downdraft through an MDF. There's so much gap, there's so much vacuum loss occurring. So the thinner the better, with obviously enough thickness to counteract for the variance in your material. Another rule of thumb, the firmer the better. We offer these products in a lot of different densities. Reason being, all those variables that we went through in the beginning. Strength of vacuum, elevation levels, size of the parts, all these different things. But we do different densities for those different applications. You want it to last as long as possible. That's why you want it as firm as possible. But it needs to be soft enough that your vacuum can compress it. So typically our low density products are intended for lack of a better term, kind of the hobby shops. Maybe they built something themselves, hooked it up to their shop vac. Smaller vacuum systems need that lower density foam, soft stuff, squishy stuff, but still has recovery. That squishy, soft stuff still needs recovery. It's not weather stripping. It needs recovery to have extended lifetime, but that low density stuff and most of the machines downstairs will probably just get flattened out quicker than the customer likes. So we go with the firmer density. Well, in our product line, our medium density is 90% of the stuff. Then the firm density is really for the very heavyweight material. If somebody throws a big slab of 4-inch oak on there and it just flattens out all the gasket before we turn on the vacuum, that's not what we're looking for. So the very heavyweight material is the firm stuff, but we want that foam to compress under vacuum, not under the weight of the material. Another rule of thumb when using onboard gasket, quick, easy, very helpful in holding those parts, but one thing to keep in mind is that the fact that it is surface mounted, it doesn't zero out. The Z depth does have to be accounted for. You can say it's going to be about half the original thickness, but it does at some point have to be accounted for in your program if you have a Z depth issue. By putting some shims down, here's his gasket he's using to hold his part. What he did here is just put a couple of shims of gasket material down so that when he sucked his part down, everything stayed flat, stayed consistent. If you just left that gasket perimeter out of the edge, sometimes those acrylic sheets may lift up, may cause some problems at the edge. If you want everything flat and consistent, put a couple of shims of that onboard gasket on there. That will allow for that consistent cut throughout the part. So some quick onboard examples that we just threw together, just different ideas. Here's a guy, well, any questions on the onboard gasket concept? So onboard gasket material, I showed this one at the end because it kind of leads into the next product, but it shows that this particular customer had a lot of parts and he surface mounted gasket all of this material. Put it all around all of his parts. I chuckled with them a little bit. They must have taken you quite a long time to do all that stuff. Because another option that we have is we'll take that same onboard gasket material that customers are applying down and trying to stick throughout their parts. And a customer like this who has so much parts, so many different things, and he spends so much time building this, that what I would probably say to him is, let's try our cover gasket. Cover gasket material is the same as the roll material, but instead of giving it to a guy at 3/8 of an inch wide, I'm going to give it to him a full sheet that he then uses his own CAD program, his own parts, to make custom gaskets for himself. It's the same material, but now instead of 3/8 that he's sticking where he thinks it should be stuck, we'll give him a full sheet that he can cut out any shape he wants. Typically, they'll give it to him blank, maybe use an engraving tool, cut the OD, the ID of your tool path, where your vacuum pocket's going to be, remove your tool channel, your vacuum channel, vacuum source hole. And now this 2.5 inch star has its own custom gasket to get the vacuum pocket out as close to the tool path as we can. If you were to try to gasket for this part using one of the other methods, difficult to get it out to the edge of that star.
All of these methods are, you perfectly suited, uniquely suited for profiling and perimeter cutting. What if the part requires some precision pocketing that's important for hardware installation or some other application? You really need to know, obviously the onboard wouldn't be good for that.
Nope.
But even your other, you convinced in most all situations you can get that down to where you are zeroed out.
That's where you'd want that. Two ways to do it. You could either do the inboard gasket, where you're out of channel, bury that gasket, bring it flush. Or we'll have a situation where if the part is so small, the reason customers will use, this is now back to the cover gasket, intended for use for repetitive small parts, back to a dedicated fixture environment, right? The inboard gasket was for a dedicated fixture, dedicated job. Cover gasket, same thing. This is a dedicated thing. If we're not going to use this sheet, cut all these stars out, and then say, now let's do our circles. Once you make your star into this sheet of gasket, it's done. You can't erase it and start over. So we're obviously making dedicated fixture parts here. If you did have a surface-mounted gasket where you're trying to hold a very tight Z depth tolerance, one thing a customer may do is put an additional shim type product in there that is inside the gasket perimeter, so that when the gasket compresses, because it's not going to reach the fixture, it can't hit the fixture because it's an accordion on top. You can't turn an accordion into nothing. It's got to stop somewhere. But if you could put some type of shim reference point within your vacuum pocket area, then you have your reference point. But the inboard gasket would be the best way to do it, because you don't have to worry about shims, or you'll always know where it is. Another thing is parts with excessive holes. At first it had one hole, but something that has a lot of different parts, limited surface area. That's where the sheet material, cover gasket material comes from, is we're just having such a tough time dealing with the limited surface area that we have. That's the surface area is where the vacuum needs to hold on to, and when that surface area becomes limited, the sheet gasket allows for maximum use of what is left behind that we're trying to clamp onto. One of the benefits is you get to use the existing CAD work. You've already done that, like I say. So you're making custom die cuts in-house for your job based on your own CAD program that you can make. Maximizes the surface area and low setup time. We've had guys who will say they can make these fixtures while they're at lunch because the machine's doing it all. They don't have to spend time gasketing by hand, doing other methods. Sometimes the CAD work, the machine can make these fixtures based on what you've already done.
What's the cost difference between the cover gasketing by the square flat gasketing?
Well, not quite a apples to oranges comparison, but let's just say a sheet of gasket material for our customers, call it $200 for a 5 by 10 sheet, 5 feet by 10 feet. Or I should say 4.5. We don't have 5 wide. We can't go 5 wide. 4.5 wide, 10 feet long. That's about $200. And we can change products, thickness, size, price, but for ballpark, call it $200 to cover a full sheet, versus when you get into the rolls, a little tougher to how much lineal footage are we using to do a cabinet door or a bunch of stars. I mean, we're talking difference of lineal footage, so, but let's just say a roll of 1/16, 3/8 wide, same material, 150 feet for about $20. And I got all the samples we can hand out, see which one is right for you, but if we can eliminate the onion skins and the tab cuts, that's where we start to get into that savings. Adhesive on one side, yep. Sure, I mean, we can find difficulty in applying anything, and there are some application tricks that customers have taught us over the years, kind of like applying a decal. Sometimes you take that first couple inches, stick that down, and as you peel, because paper doesn't stretch. All right, paper's not going to stretch. The foam will, if you're applying the foam by itself, and that's where you get some of those bubbles, some of those waves, whereas if you can start to apply it down with the adhesive on there, sometimes the adhesive is actually on the belly of the material, the paper's on the back. Sometimes they'll just lay it all out with the paper on there and then take the paper off in one shot to keep it consistent and flat. That lip of the freezer door, we want it as flat and as consistent as possible. But the fact that it is foam, even if you do have a bubble in there, some pockets, a pin to get that air out, flatten it out, gets you that base that you're looking to do to create that seal, that universal seal. It cannot be laser cut. If you laser cut PVC foam, void your warranty on your laser machine that day, and it also has some outgassing. So what I've been told is no on laser cutting. I've never tried it. Some people have said that you can try it, but I've never done it, and I wouldn't recommend it. I'm sorry? How do I know it's PVC? Yeah, PVC foam, so the outgassing is not recommended. When we cut this, we die cut it, or one thing that customers can use to do this, the way we did this was an engraving tool. You can use, if you wanted to make this channel with your 1/4 inch bit, your traditional flat bottom 1/4 inch bit, you could do that. You could certainly do that, cut that channel. The issue would be you're going to get a rough edge. You're going to get a harried edge of gasket, which isn't negative in terms of the ability to hold vacuum, but as you load material on and off, sometimes that rough edge may catch material, and the fact that it's adhesive anchored in place, we're really relying on that adhesive to hold it down, and the more rub that you get with a rough edge probably isn't ideal for keeping it in place. So a clean edge with an engraving tool allows you to get that really sharp looking edge and get that maximum vacuum area. You could do a drag knife as well. Yep. I have not heard anyone say a wheel cutter, but I don't know why you couldn't. Yeah, you could do a knife. It's really, and it doesn't have to be perfect. I mean, because the gasket material is what's going to create that seal. How you get to what you leave behind is kind of up to you. The CAD work can do it. That's one of the benefits of using this is we've already done the star in the CAD program, and just with a series of offsets, we can usually figure out where all these channels need to be.
You're saying engraving tool, you mean like a bead cut?
Yep. So some of the rules of thumb when we're talking about cover gasket material, we do have the ability to really leave behind whatever we want. And one of the things we talk about is this wall. How big do you want to leave it? You can really manage whatever fixture you're building for yourself into any shape that you'd like. Here's an example of an engraving tool being used to cut those parts. Cut those inner and outer edges of that tool path. Offcuts and plunge holes need to be accounted for. Same thing as any of the other parts that we have a dedicated fixture, not universal downdraft. We want to be able to have vacuum part, get vacuum clamp out to the edge, get it around these strange pieces that were giving us trouble before. You want to make sure you hold on to your offcuts. This waste piece is now being accounted for. It talks about the holes. Here's an example of a part with a bunch of holes, right? We've got 4 corners Got a small, about a 3-inch square block made of a very high density polyethylene, very difficult, dense material. This guy was trying to cut these parts with 4 holes in it with simply downdraft through an MDF spoil board like his rep told him to, and guess what? Couldn't do it. So we gasketed, created a dedicated fixture. These gasket holes here now account for those. So he puts those holes all the way through the part, and when he does that, his vacuum area has not been compromised. His vacuum chamber hasn't lost that pss, pss of air. He's got all that power of the vacuum pump continuing to work its way towards the part. That's where it needs to get to. It's got to get from the pump to the part, and we need to eliminate all the loss on its way. And this is one way to do it so we don't get those holes. We've got a vacuum source per part. Some of these little shims here keep everything flat and consistent as we cut those parts, and 0 vacuum loss. Another example of cover gasket. This was only right before this last Christmas. Customer doing, I don't know, what's that, 2.5 inches, 2-inch parts with a hole at the top. And he was having trouble. He said he had, let's see, I applied the gasket to the melamine sheet and used an engraving bit to make the gasket shapes. The cutting portion of 113 parts takes 5.5 minutes. I have 2 of these jigs, and they take about 90 minutes to make. Now I'm making all of these parts in a single pass, full speed. I have cut 120,000 so far. I suspect we will do at least 200,000 this year. I would not want to dedicate the time to make these without a fixture. Jason, Scott Custom Woodworks in Utah. This is a real-world example. This guy was trying to make, it ended up being 300,000 Christmas ornaments last year. He had a rush job. Middle of November, he needed to make 300,000 Christmas ornaments, and he was doing it in 3 passes. 3 passes with the hole through a downdraft MDF spoil board. I said, that sounds like you're not making 300,000 parts. Sounds like you're making 900,000 parts if you got to do it in 3 passes. It's a lot of parts to cut, a lot of times for that thing to go in a circle. Is if we can make a tight, airtight fixture, melamine board, don't allow air leak, he was able to increase the speed, running at full speed. He was doing 3 passes at half speed. Now we're doing 1 pass, full speed, finished parts. And that's what we're trying to do. We're trying to get more production out of the machine. So what we've done now, move on to the 5th and final product group that we have, is our tile gasket. Tile gasket is the same material as our sheet gasket. All the products are the same, whether I cut it to a 3/8 wide or I supply it in a sheet or I supply it in a sheet with holes. All of the products are the same PVC, closed cell material. Actually, take that back, not closed cell, we call it microcellular. A closed cell item is actually similar to the weather stripping that you have. It is a closed cell item that doesn't allow air to pass through. The majority of our foams, microcellular, if you stand it on its own, do a scientific test, you actually can get a little bit of air to pass through there, but once it compresses by 2 to 3%, then it becomes a closed cell item. And what that allows is that recovery that the weather stripping doesn't get. So a microcellular material has a breathability, has recovery to get that seal up above. A lazy gasket doesn't seal. You need that strong push up against the part up above it in order to get that vacuum seal all the way around. So we've taken the sheet material that a customer will customize for themselves, make for their own dedicated fixture, for their own dedicated part, and we've supplied this now back to the spoil board world. The folks that are looking to spoil, looking to chew up something because they're never doing the same thing twice. We give them the tile gasket. The tile gasket is intended for those looking to improve their downdraft in a simple MDF downdraft environment, which is the majority of shops. Just strict downdraft through an MDF spoil board is the way they're holding their parts. And this is for those folks that are looking to improve that process. We say looking for improved vacuum, but they don't have the time to do the fixturing. They don't want to make individual parts. They want to eliminate onion skins and tab cuts. They want to eliminate one of the employees from going over the wide belt sander and cleaning up all those onion skins and tab cuts, moving it over there, all that stuff. They want to have that single pass finished part. And again, we're going back to a spoil board environment because we're going to spoil this. This is not dedicated. This is for that constantly changing over system. So tile gasket, the rules of thumb that we have for our tile gasket material. First thing is, when we look at this, looks a lot like the pegboard in your garage. It's the same pattern we used. A 1/4 inch hole every 1 inch. When you do that math, that means that 85% of your board now is a closed cell gasket seal. 85%. 15% are the holes. And now the vacuum pressure that pump that you have is producing, which is constant, right? You can't turn up or down the volume of your vacuum pump. It is what it is. But we're trying to eliminate the loss. That's the number one thing. Just get rid of all that stuff that's happening, all that loss, seal it in. And your MDF spoil board is a 100% surface area of loss. There's loss everywhere on that MDF spoil board. In this case, we've sealed 85% of it. So we don't get all of that loss. And as you start to cut your parts, you don't get loss of vacuum. That's the number one thing. We set the tooling to barely cut into the gasket. So we're just trying to kiss that material, just like you would your MDF spoil board. Just trying to go down, kiss that material, barely chew into your spoil material. Not the spoil board. In this case, it's going to be the spoil tile, the spoil gasket, because we are going to spoil it. And we're trying to go through the parts and just touch that. Because if you can just touch that gasket material, you can get extended use out of it. You can cut your square parts, you can cut your stair risers, you can cut your parts over here, and you don't necessarily always have to worry about sealing up. You know, I put an acrylic sheet down at that end of the table to seal it up. Well, now we got 85% seal. You get a much more efficient use of your universal downdraft MDF spoil board. And if you just chew into this, you get repetitive use out of it.
Is that feathering the tile shredding?
I'm sorry?
That feathering texture?
This here?
Yeah.
Yep. So that's my guess. They're probably using an up spiral bit, so they're pulling that foam up a little bit off the material.
But that's not going to affect it since there's so much other clamping, there's so much clamping pressure.
Exactly. Yep.
Pressure everywhere else.
Yep. So what we do as a service to our customers is we punch all these 1/4 inch holes into a sheet. Looks clean, it looks uniform, it looks nice. And then we get to our customers and they start doing this to it. Now those holes that we've put in there create vacuum clamp, VACUS, right? Back to the void of matter, void of molecule. We have a pocket now that has the ability to produce that void of molecule, to create suction cup. Now a 1/4 inch hole isn't much to hold onto a cabinet door, I get it. But when you multiply all those holes over a 4x8 sheet, we're talking 5,000 holes on a 4x8 sheet, 5x10 even more than that, and we're just getting two things. We get loss prevention because we've sealed 85% of the spoil board, and that vacuum pump that you have and all the power that is constant coming out of that machine, can't turn it up, can't turn it down, all that power now, instead of get 100% use, gets 15% use, and all that power goes into those holes, and it creates clamp because we have a sealed edge. You can't create a seal without gasket. If we're just trying to suck right through an MDF board, a lot of loss of air there. Once we seal, different ballgame, different clamp mentality, different science. So now we're using the science of vacuum clamping with a sheet. And like you say, once you start going into this, that's caused by the ability to cut that part where we have to go through, because I want my customers to go through the part. I don't want them to onion skin. I don't want them to tab cut. We want finished parts, single pass, quick, efficient. If we're competing against China, we got to do it fast, we got to do it clean, we got to do it the best way we can. That means single pass. And now when this guy goes into this material, it's inevitable, right? You come back from lunch and Dave just put a whole big old gash into the tile gasket you just laid out. Say, man, now what? You put a big 3-inch gash right here, all this tile that we just laid out. You put a part on top of a big 3-inch gash right there, it's the same thing. We still get vacuum clamp. So as you wear this material, as you put holes in it, as you put cracks in it, it's still a sealed edge. the vacuum still has an ability to create vacuum because you have a perimeter area that you're pulling the vacuum from and creating clamp. So as you wear it, it doesn't lose its effectiveness because it's still creating seal over the entire spoil board, and whatever holes you've started to put in will still create enough clamp to hold on to your sheet as you're cutting that part. And then, as one tile gets so worn out that you think it's time that this thing just isn't doing well enough, you just replace one tile at a time. You don't have to resurface your spoil board. You don't have to reset your Z because your spoil board now is an 1/8 inch lower and try to figure out, hey, do we reset our Z after lunch? Because we did do that fly cut. I can't remember if all that stuff's eliminated. We just go, this is now the surface, this is your tabletop, the tile gasket material, that's where you kiss all day long. Don't have to go deeper. And if we can dial in that Z number the rest of the day, the rest of the week, the rest of the month, because we're never changing the thickness of the spoil board, hopefully we can get that dialed in pretty good and just keep cutting parts, keep throwing sheets on there, keep getting maximum vacuum clamp on the sheet for those constantly random parts.
What size of those tiles come in?
12 inches by 16 inches. We supply it usually in a box of 25 tiles. 25 tiles is enough to do a 4x8 sheet plus one extra tile to do your first replacement. $200 roughly for a 4x8 sheet. Now, who has purchased, what is the 4x8 sheet of MDF these days? I mean, that's continuing to rise. So, some shops I've been to, they're fly cutting their spoil board 5 times a day. And everyone's gonna ask, well, how quick does this wear? And the guy who's fly cutting his spoil board 5 times a day because he keeps going into it is probably gonna go through these a little bit quicker than the guy who says, I only fly cut once a month because we do such a good job of barely touching the spoil board. So it all comes into what the shop does on their own, but the idea of clamping, sealing is what the tile's looking to address. Yeah. It should do, as long as you don't keep it in direct sun, heat. If you got a cold freezer, you can keep it in there, and that's probably the best for its long-term use. But shelf life on gasket material should not be an issue for you. Then the wear is not necessarily a shelf life issue. At that point, it becomes a production issue. Like how rough are we on this thing? And these aren't miracle makers, right? We haven't been invited to the White House yet for what we've done for American manufacturing, but it's addressing the business issue of vacuum loss. And some of the top dogs at, I won't name the company down there, but say, hey, how's this going to affect all my automatic load and unload? And yeah, there's an issue there. Don't be rough with it, right? But if we can eliminate the onion skins and tab cuts, it's, how about we get a $10 roller at the end of the machine, and that way we just roll it on, and there's ways to get around every situation, and the folks selling the routers ask those kinds of questions, where I'm usually a little more interested in the types of questions that the customers have, the users have. They're the ones that have the real issues, not the guy trying to sell a concept. Yeah.
So double-sided laminated 1/4-inch, I don't know, whatever.
Mm-hmm.
You can replicate the same kind of situation, I think.
As the tile gasket?
Yeah, right. But you can just do it all yourself and just have it on 1/4-inch, and as long as there's the same size. I mean, the 1/4-inch plywood is like $30 or something like that.
You could, absolutely. What you're missing, though, in your scenario, is the lip of the freezer door. You don't have the seal, and that is what keeps the vacuum pressure in. We could make a tile. No, I mean, we could use, instead of this punched out of gasket material, if I gave a guy a piece of 12-inch by 16-inch pegboard that looks just like this, it's not going to work the same manner because it doesn't have the compressible foam sealant that is acting as, yeah, when two pieces of material go up against each other, you get your, going all over the place. Once you put those two solid surfaces together, your microscope can see that there's a hairline gap in there. There's daylight coming out of those two pieces of material that are up against each other. And the gasket is what closes that daylight gap. Yep, so let's say we go to your shop and today we apply tile gasket to your entire MDF spoil board. Sounds like the concern is how much leak is occurring out of these holes, right? If we're cutting apart and these holes are exposed, how much vacuum are we losing out of there? Well, whatever we're losing out of that hole is a lot less than what we were losing yesterday out of this. This was 100% loss. We were losing everything out of here. So no matter how much you lose out of any of these holes, it's far, far less than what you were losing yesterday.
But you're not aware of any kind of like design adaptations or like, like Aspire having like some kind of tooling that would say, well, I have this quarter-inch holes under my designs. Try to place designs, tool pathing the way that it's
I don't think that's as crucial as you would think, because I can go to a shop tomorrow and we can take an MDF spoil board that's across this entire 4x8 table, and we'll turn on, I'll take the part and ask him to turn on the vacuum and ask him to move that board, this little piece, across the MDF with the vacuum engaged. And typically his niece could come over with a couple of fingers and just push it around. I mean, there's not enough vacuum through a 4x8 MDF downdraft to hold on to this piece. And we'll just put a piece of gasket material on there, suck that down, turn on that vacuum. You can see that foam compress as that gasket, you see it suck down as that gasket compresses, as the air is pulled out of there, and a rubber mallet can't move that. Even with the rest of the 4x8 sheet exposed, it's because once that initial vacuum, we pull the air out of that pocket and we create vacuum under the part, it's gone. We've removed the air, we've created vacuum, and whatever is leaking elsewhere isn't as much of an issue because we've created that clamp and we have a solid hold. But yes, wherever there is leak, there's more points of loss, but it's far, far better, far less loss than you would without it. Yes?
Do you recommend perimeter sealing the MDF board, and do you sell it?
Few answers. We recommend it. We have this, we call our edging tape, just to help wrap around the edge. Some customers will paint it, some will seal it, some will edge band it. So we would recommend that on an MDF spoil board for the sole purpose of percentage points of loss that are occurring through the size of an MDF spoil board. It's a percentage point. If somebody is saying they're having a tough time holding their part and they're not using gasketing, if I edge my spoil board, is that going to make an improvement? And I can say, maybe it will. We're gaining vacuum pressure. We're eliminating some of that loss. But before I send you some of this edging tape, can I at least try to send you some gasket material? Because this is kind of the seismic change difference. We are now creating vacuum clamp, where if you're just downdrafting all the time, you just don't have that seal. And yes, we're making percentage point improvement by eliminating the loss through the edge of the MDF spoil board, but we're not doing percentage point improvement here. We're doing scientific change when you have a gasketed perimeter that you can pull the air from. So yes, we recommend it because it's always improvement. Anything that is headed towards improving something is worth recommending. But the seismic change of vacuum clamping begins with the idea that we have an area that we're pulling the air from, and the fact that it's sealed off at the edge just ensures that the vacuum pressure that we're trying to produce becomes that much stronger, because all that loss that's occurring has this, once the vacuum pressure leaves the system, it doesn't come back, right? And if we're trying to get that suction cup on that part, that hold gets less and less, the less air pressure that's in the system. So, yep, that's going to help keep air pressure in the system, but it's the gasket that is the real difference maker and that aha moment that we need to eliminate loss under the part. And we do, and so we do sell some things and paint and seals, but that's the idea. That is one of the downsides of it. We are active, and if anyone has ideas for me, because customers ask me for this kind of thing all the time, I would love to get some kind of paint seal, because that is the downside. I am aware that folks that wrap their spoil boards aren't doing a dedicated fixture, right? If I tell them to use a dedicated fixture, non-porous board, there's no need to wrap the edge because it's not leaking out the side. So I know that my customers who are using the edging tape are using it on an MDF spoil board environment. If they go to fly cut that, it does get in the way. So our own product is not the ideal scenario for edge banding an MDF spoil board. We could do that. I'll send you a roll, no charge, and you can let me know if it works.
For the outside edge, you know, if you're gonna apply that, why not just paint? Yeah, just paint, that's what, and then you can, apply that's a little tedious, but paint it, seals it, and then you don't have to worry about it. Lacquer's cheap.
There's an adhesive material that I can just stick on the
Yeah, I like your idea that why wouldn't a foam gasket work? I mean, I don't know why we're selling red tape, you know, 3/4 inch. We cut it, so I'll give me a card, I'll send you a roll and you can let me know if it makes an improvement. Sounds good. Wrap up here, I'm already out of time. So we're looking for improved vacuum, and then we got a couple of rules of thumb, 80%, 85% I think are going through these, and then just some examples. Here is a guy making snowboards up in New Hampshire on a multicam machine. Interesting here is he just has a dedicated board, not a 4x8 sheet, not a 5x10. He makes all of his snowboards out of one particular shape, and he just took a board dedicated to that shape and covered just that. And he can take that on and off the table, move it wherever he wants, and has a dedicated random part fixture, spoil board, that he can take on and off the machine as he gets these parts. One other example, not to hype up the snow sport industry, but here's a ski shop that we went to in Reno, Nevada. Visited with these guys for a day. They were having a tough time doing parts. Kind of came up with an interesting concept here. Same kind of deal, that they had all of their ski parts out of a particular blank size. And what we did was he sealed his entire spoil board, and we ran just gasket down the middle underneath his blanks. Few unique challenges with this guy in Reno. One, because Reno is higher elevation, they have a tougher time holding parts, because if we're talking about vacuum and that vacuous concept, air pressure, the more air we move from under the part, the better off we're going to be, because the air above can sit on it. Denver has less air, Reno has less air than Miami. So we need to get even more air away to get that air pressure differential. There's just a differential challenge that Reno has, so that's why they call us in. They were having trouble calling the parts. One of the unique things that I had not seen before is they had one of the challenges, one of the questions they had about using this tile gasket material was what kind of tolerances are we going to be able to hold, especially out at the ends here, because we have thin parts. They were actually machining into the blank the concave taper of the ski out of the blank. So you could actually see down here, it got a little thinner down here because they tapered it down. Turned out they kept the tolerances just like they wanted to, able to get these, they sealed the rest of the board on the outside, start cutting their parts, get those edge. Another unique thing I found, there's no replicating a customer visit. I can talk to folks all day long on the phone, but I learn the most when I see what they're doing, work with them. And very interesting, he wanted to lay these tiles out, one on the table. I didn't want to do that. I stayed off the table. But then two, he laid the gasket out across the table, and we laid them out as we worked our way down the table. Made sense to kind of get everything ready. And he turned on the vacuum while we were laying the tile out, said, "You're the boss." Because his concept was, as the vacuum's on, we were laying them down, the vacuum would just kind of help hold it in place. But what I found very interesting is as we were walking our way down the table, taking parts on and off to lay down, we got to the end of the table and just peeling. It was just a little bit more vacuum pull on the parts we were just trying to take off that MDF board. Not as much at the beginning, but as we start to seal that spoil board, as we start to put more tiles on and the vacuum is getting less leak through the board, the vacuum pressure of the system just got stronger and stronger as we start to eliminate that loss. So it's the concept of vacuum loss prevention is really the thing that we're trying to do, more than just increase the strength of the vacuum pump. Too many people are told, you can't hold your part, you got to go get a new vacuum pump. Sorry. And I'm not ready for my guys to spend 50 grand on a 20 horsepower twin pump where I said, if we get a proper lip on your freezer door, let's try that before you go start spending more power to just mass downdraft through an MDF spoil board. So that quick wrap on improving vacuum performance with CNC routers, products and techniques. At All-Star, we have kind of a tagline, hold it better, cut it better, profit better. And you've got to do it in that order. You can't cut it better if you're not holding it better. Vacuum is the only thing we're asking to hold the part. We need to improve the vacuum to hold that part better. And if we can hold it better, we can cut it better. And that means cutting it in one pass, cutting it cleaner, cleaner edges, less tooling, less changeover, less challenges. Let's cut it clean, let's cut it quick, let's move on to the next part. And if we can do that, maybe we can compete against some other groups out there and do American manufacturing here and do it with the investments that we've made in this machinery. So, any questions? We do have a booth. So, what are we? 1768. Yes, yeah.
And then, I was feeling super confident about that. With cutting those out, such a small amount of area, vacuum space, and 2 inches, 8/4 hardwood. Just that lateral pull that you get from.
Were those the puzzle pieces that were they a foam core?
No, the foam was just like our prototype.
But those were your photos with the letters on there. Did you? Yeah, let's chat later, because those are small parts, for sure, and it looked like you created did you use Onboard gasket, it looked like?
A couple different options.
Yep, so holding those small parts, and what was the challenge?
Hitting that top end, and I've had the same problem with other thick stuff. It's just a different force that's applied to that whole, all that material. When you're hitting it so high, or when you're cutting so much compared to some really thin stuff.
Yeah, because it's the torque. It's the amount of torque that's occurring, and obviously the more torque that's occurring, the less the negative it is on holding that part successfully. So we got to clamp it better, and if we're still not doing it, but obviously the bigger the tooling is going to be more force that is part of that pass-fail test. Is the vacuum working well enough? Because we're not perfect. If we had the perfect vacuum, you could hold on to anything. You could hold on to a head of a piece of rice if you had perfect vacuum, but we know it's impossible to get there. But I know there's leak occurring, and that's why the size of your part gave you trouble, is because there is a leak somewhere. And sometimes it's easy to see where that leak is, and we can fix it quick and make a noticeable difference. Sometimes it's not as easy to figure out that we have some leak. somebody came by the other day and said, we were looking, they were sending us pictures, we could figure, everything looked great, and we could not figure out why we weren't getting parts to hold down. Turned out he had a kink in his hose underneath the machine. Like, it's like all stuff we're not even looking at. So there's loss, vacuum loss occurring somewhere that we need to eliminate. And if we can eliminate it, that power of the pump gets to the part. And that's where it needs to be. All that loss that's occurring in the hose, the fittings, the spoil board, the tabletop, we got to get that vacuum power right there in order to hold it as best we can. There you go. Thank you, guys. Yeah, we are at the booth 1768. We should be there in a short amount of time. So if there's anything else I can answer, I am more than happy to do it for you guys. Thank you.